contained in the OpenStack. Wow, thank you. That's great. So it's going to be a set of infrastructure, rebars on the side, Packet at the bottom, CentOS, then Ansible playbooks that are maintained in the community by Kargo, called Kargo, then Kubernetes, and we're just pulling Kubernetes down out of the Kubernetes repos. And then on top of that, Helm, which is the Kubernetes templating system. And then from Helm, we're using OpenStack, what are going to be OpenStack Big Tent Helm charts. And those then direct Kubernetes to install OpenStack inside of Kubernetes. Enough. It's actually even a little bit more complex because there's Helm charts for Ceph, and so we build Ceph. Ceph then turns on something called stateful sets in Kubernetes, which allow you to have persistent storage, and because you need that for the database, and then the Helm charts use the persistent storage when they build the database on top. It's a big stack. And it's reflected in this graph. If you see it, it actually goes all the way through all the stacks. And you can go look at the Helm charts that we apply in the order and things like that. It's everything I'm showing you is open. You can go to Digital Rebar and see the Kubernetes. It's under Kubernetes workloads and all that. Digital Rebar workloads has Helm, Ceph, OpenStack. Hold on. I thought I had preloaded that. No, I didn't. So under Digital Rebar workloads, you would have, there's Kubernetes, OpenStack, Helm. There's a whole bunch of stuff because this isn't the only thing that we deploy, but it's a nice example. Other questions? Does that seem like a lot to everybody? If it does, then that's actually yes. And we'll talk about, wow, that's a lot of stuff, because that's the subject of the talk.
How are you, is there anything, maybe the COLA or like stack?
It's a great question. So the question is, of the various OpenStack, Kubernetes under OpenStack, that's actually the topic, that's the talk. This does not. So this does use Stack-and-Eddy's containers. It doesn't use the COLA containers. But it doesn't use either one of those approaches. COLA ended up being a lot of Ansible code. And so it really was an Ansible project that used containers. Although they sort of decided they were going to use Kubernetes and then went to Helm charts. But that was sort of after this stuff got started. And then Stack-and-Eddy's was its own way of doing things because it was sort of very early, not a Helm-based thing. Helm is a community project maintained in the community that's really handy for basically showing up with I need to deploy foo. It's still pretty low level, and it's not a pass at that point. It gets a little bit further. Good question. I'm about to dive into the slides because if your questions line up with the slides. Are there other technical ones on the stack or the tech? And I can dive as deep into this stuff as you want and do other demos and things like that. But I love live demos. It's crazy fun. Slides. That's not slides. That's a good demo. That's a good demo too, though. All right. So this presentation is one that I have given at the OpenStack Barcelona Summit, and then I gave an update for it somewhere else. At OpenStack Mountain West, the one in Salt Lake City in the middle. And I've updated this because I was much more jaded when I gave this talk the first time. And just full disclosure, I felt that this was going to not be a good idea. And I've watched progress go through much more quickly than I expected in being able to integrate OpenStack on top of Kubernetes. So the short answer is, if you think this is a bad idea, like I did, I have come around to thinking this is actually the right thing. And in partly, I think that this is going to happen, and I think part of it is that it's going to make Kubernetes even more powerful as a platform. Right. We'll talk about some of the impacts. My background, I was on the OpenStack board for 4 years. I led the interoperability efforts on the OpenStack board, so really worked on something called DevCore, if you're familiar with that. In the Kubernetes community, I co-chair the Cluster Ops SIG. So when I showed up at Kubernetes about a year and a half ago, I really wanted to not repeat the operational issues that OpenStack has had, so I tried to lead in the ops environment. That's a whole nother line of questioning we can save to the end and where that's going. And then I'm co-founder of Digital Rebar and Crowbar. Crowbar was the first OpenStack installer. SUSE still uses it. Digital Rebar is like 3 generations past that, but that's where the hybrid infrastructure automation pieces come from and really trying to automate these types of problems. And that's what I already talked about, RackN. And so when you look at what this talk is targeted for, it really talks about addressing operational needs. So I'm not trying to be an upstream contributor to OpenStack or an upstream contributor to Kubernetes. It is about operating those infrastructures, right? I'm a very firm believer that the operators of these infrastructures, and when they're successful, do not expect to be submitting patches to the code except for fixing bugs. And even then, a lot of times they want to submit a bug and get it fixed. So they want to run the infrastructure. They want to talk about running the infrastructure. And I think it's very important that if you're going to be a super user on that infrastructure, you shouldn't have to learn the infrastructure to use it. So the idea would be, I can maintain Kubernetes without learning Kubernetes. I can maintain OpenStack without learning OpenStack, right? You shouldn't have to be a power user of OpenStack to run it. But when you think about things from an operational perspective, that means that the community has a responsibility to help operators be successful. The operators aren't responsible for doing that on their own. So you can't push the rope from that perspective. You have to help the operators be successful. So that's a lot of what this talk does, is it starts from that position and thinks through the operators at the end of the pipe, not putting the operators in front and saying, fix it yourself. I really don't like that as an approach. And to give you a roadmap of what we're talking about here, when I say underlay, not everybody understands what underlay means. Underlay is the idea, this bridge between the physical infrastructure and the application that you want to run. So it's a part of the platform where you're dealing with physical concerns. In networking, the network underlay is the switches. In physical, when we're talking about this, I need to worry about the NICs and the storage and the drive information and the operating system and the BIOS and the RAID. That's all underlay concerns. And in this case, this is what I would call the Kubernetes sandwich, or the OpenStack sandwich more correctly. But we are talking about putting Kubernetes under OpenStack. There are a lot of people who talk about doing Kubernetes on OpenStack also. It makes no sense to me or anybody I've talked to do both. Right? That becomes sort of a silly exercise where OpenStack has no material value in that. So since most people in the room know what Kubernetes is, I'm not going to spend a lot of time talking about it, except to make a couple of important notes. One is Kubernetes is not really orchestration, it's scheduling. And I'm not going to spend a lot of time dwelling on the difference, but it's going to help make sure containers are running on the infrastructure and they keep running. It's not really designed to handle workflow issues and things like that. And it's designed for applications that are designed for it. A little bit circular, but the idea is we're not expecting you to take an existing application and just move it to Kubernetes and not have any port or migration or rewriting or things like that. It's getting a little better because we've introduced the ability, and some people really hate this pattern, but what they call a stateful set used to be called a pet set, where you would be able to persist data in a container and then move that container around. And that, a lot of people don't think that that's even a good pattern. It sort of breaks a lot of the Kubernetes goals, which are immutable infrastructure, 12-factor. If you don't know what those things are, we can talk about it, but go research it. If you're doing containerized work at scale, those are key concerns with actually being successful with apps. The point I would make is that OpenStack was not designed with this in mind. So it's just the reality of how OpenStack was designed. This is a graph we put together in Cluster Ops for what Kubernetes is. It can look a little scary. The good news is it's not getting any more complex, and it's really not complex at all. If you strip away a lot of these extra services and layers, Kubernetes is really just two things. It's a server, an API server, and then that server is the center of a star of a whole bunch of things called kubelets that manage containers on a whole bunch of nodes. So it is pretty simple. There's a storage system called etcd where the data is persisted. So it really ends up looking very much like a 3-tier app. So not a lot of heartburn over Kubernetes and the way Kubernetes is structured. It's a very sound infrastructure. But people have a tendency to look at Kubernetes, hear about it, and the enthusiasm people have for it, and think that it's going to generate rainbows for them with free upgrades and automatic HA, fault zone, tolerance is great, all this stuff. And it's not true. There is a lot of benefit that you get from using Kubernetes towards those capabilities, but it's not there. If you go back 6 months and you look at my previous slide of this, I've actually, you can see my statements, and I try to be accurate about where I was and what I see. OpenStack operations still not a solved problem. There's a lot of people doing it a lot of different ways, still arguing over the right ways to install OpenStack. Kubernetes has the same problem, and we can talk about that at the end. But Paul and I have already gone back and forth on this. I know you're waiting. When I look at the community, most of the new deployments I see, even things that were traditionally not container-based, have rolled to container-based. That doesn't mean they're Docker-based, but they're definitely putting OpenStack components into containers for isolation. Even O now has been moving towards a container-based solution. Mirantis' stuff was going there. Rackspace's was. I think IBM's is. Maybe not. Maybe you guys are the outliers. But as far as I've seen, everybody's now packaging their OpenStack deploys in containers to some extent, which leads people to say, well, if I'm using containers already, if I rub Kubernetes on it, I'll get all these great behaviors. And this is where the presentation sort of kicks into high gear. Kubernetes is still new. There are not a lot of people who have done and know how to do production deployments of Kubernetes, let alone upgrades and stabilization and networking, and Docker keeps changing and breaking things. And so we're not quite at a place where if you were looking for a enterprise HA OpenStack deployment, that putting it on top of Kubernetes is going to give you a lot more stability. It's just the fact of the maturity of the platform. And even if you did all that, it doesn't mean that rubbing Kubernetes on it is going to make OpenStack HA or upgradable. Because those issues are actually OpenStack issues, not Kubernetes issues. You still have to be able to handle how do you upgrade a database, how do you change, incrementally change versions of agents and clients, and how do things interact with each other when there's mismatches of versions, and how, those are not handled by Kubernetes. They're made easier, it's made easier to change things in Kubernetes, but version tolerance and API mismatching, those are app issues, they're not platform issues. Okay. The good news is this used to have some red in it that we're significantly better than we were even 6 months ago. And there are real benefits, right? Docker packaging does help people manage Python dependencies. We do get upgrades from Kubernetes built-in process. So you can go ahead and say, oh, I need to change the Nova client on 100 machines. You can issue a single command and actually change the Nova client on 100 machines. It's pretty awesome. There is job schedulers, so you can do maintenance. There's a whole bunch of infrastructure you get for free. You can get fault tolerance in key components because Docker or Kubernetes will make sure things keep running. So you can say, I need you to keep running 2 copies of my database server, and it'll do it. So that's really impressive. And then if people are actually adopting Kubernetes, and this is going to be the market question that you're going to be thinking tonight, right? If Kubernetes is going to be a dominant platform in data centers, then showing up into a site that already runs Kubernetes, it could be really easy then to install OpenStack, if what I'm showing you is accurate, right? Because I just did a standard Kubernetes install. It's the same Kubernetes install I do for everything else, and I added OpenStack to it. So that option becomes really interesting from an OpenStack market perspective. And I have a slide about that. Because it really is going to come back to community size for Kubernetes. Right. The thing that I see is Kubernetes will be a bigger community than OpenStack. Right. It runs in the cloud. So you don't have to buy a server, you don't have to use a server, boot a server, install an operating system, you don't have to deal with networking. You can go run a command line and install Kubernetes on Amazon. It'll take you about 5 minutes to do it. So when it's that easy to use, the community for Kubernetes is going to grow much faster than it will for OpenStack. Because OpenStack is an infrastructure automation platform that requires you to have, ultimately, physical infrastructure to run it. There should be people who are like, oh, I'm an OpenStack hoster, yay, Rackspace, right, who've been pioneers for that, and that makes OpenStack accessible for you as a cloud infrastructure, and that's an important thing. But for people who are just using OpenStack in their own data centers, it's a much higher bar to get to than Kubernetes. Okay, and from my perspective, that tips the scales on usability. We will soon find a lot more people who have used Kubernetes than used OpenStack, if it's not already the case, because cloud is just that much bigger. Okay. So, hiding her face. So if Kubernetes is an underlay is coming, then we should get pragmatic and actually say, what is it going to take? How's it going to look? And I want to stop for a second because up until I saw what SAP, AT&T, the ComDev people, and there's Port Direct's a small consulting shop. There's about 5 or 6 people who are the core of this, and we've been picking up steam. RackN participates also. And actually some people from Deus have also been instrumental in making all this stuff go. So this is a community effort. I like anything in community, you're standing on shoulders of giants when you show this. So it's important to note just how much it goes into this stuff. All right. So if this is going to happen, the first problem is, especially when we go back to Austin, OpenStack Austin, Kubernetes under OpenStack is a hot mess, right? Because it tells people Kubernetes is ready to run on your infrastructure as the bottom, and OpenStack's not. And I don't think we've resolved this. I just was reading the notes from the board meeting that they had face-to-face. I think they're getting closer, which I appreciate, but it's still a problem. This message, and I'm repeating the message, I'm as much of, well, I don't have any gripes about it. Kubernetes is easier to sustain and run on a physical infrastructure system than OpenStack is already, right? Otherwise, I wouldn't be proposing this as an alternative. I think that OpenStack has been pushing a single platform to run metal containers and VMs, and I think that it's confusing if they're going to promote Kubernetes to promote that message. So I think that's something they need to address. And I think it just tells people to use Kubernetes. And if you're targeting your app to Kubernetes, you really don't care if it's OpenStack or Metal or Google or Amazon under the covers. Matter of fact, that's why you do it. So it's a challenge. As an OpenStack community, you have to look at this type of force and acknowledge what's going on and how OpenStack needs to find its place in the ecosystem, not be driving the ecosystem like we used to do 5 years ago when OpenStack was the sort of the king of the cloud, private cloud infrastructure. And this goes back to the question we had. There's a ton of ways that you can install OpenStack using containers. O, I didn't even include Stack and Eddies in this. Cola, OpenStack Ansible. There's an Ubuntu cloud install that they use their own LXC drivers. There's a whole bunch of ways to do it. And right now, it's confusing when everybody's going to raise their hand. and say, hey, yeah, we use containers to do our install. That's different than this type of Kubernetes-based install where you're using an underlay, right? My projections of this, I'll hold my projections. So containerization just means I'm using Docker, I'm using containers, they're lightweight, it really solves some packaging problems that we have with Python where we're trying to distribute a whole bunch of code and there's a lot of dependencies. So containers immediately address that. Kubernetes is something additional that's different than just I added containers into my deployment. It really brings in a container lifecycle. It really brings in a degree of mobility of those containers, a lack of control of the IP addresses in those containers, a lack of control of when the containers start and stop. So if you went back 2 years and you looked at container efforts to install OpenStack, they pinned the containers. They just treated them like VMs, or they treated them like a package. You know, hey, I'm going to start a container. It's going to run my service. Kubernetes doesn't do that. Kubernetes, if a server shuts down, it moves a container. If you drain a server, right, it's going to move IP addresses around. It's going to move identity. OpenStack's not really designed for that right now. So it's part of the challenge that we have. And there's the way we're dealing with it is sort of a workaround. Okay. So the assessment that I have is that what I'm seeing so far with the approaches that were out of Kubernetes with Helm, that it's so powerful to be able to do it like this, that this will start sweeping in the other install mechanisms, that people will start saying, you know what, I just am going to converge to this type of Kubernetes-based approach. Because it's very straightforward, it's very manageable, you get a lot of benefits from it. Whereas something where, like the original Cola did a lot of what I would call PhD level Ansible to position containers and run containers and doc, right? I do a lot of Ansible, and I was like, oh shit, man, this is incredible stuff. And I take notes, but then I was scared. And so what I think you have to be able to do is the Kubernetes stuff actually simplifies, and that's what I looked for. If you look at the original presentation, I was much angrier about what I saw going on, because I felt like we were just throwing more complexity into the mix. When I looked at what we were doing with these Helm charts, it was simple. And that, to me, back to the operational hat, it needs to look simpler, right? We can't add complexity. And so this is a very simple, next slide's better, description of what we're talking about, but it's using the Kubernetes 1.5 or above primitives. There were things that came into 1.5, like stateful sets, that are required. 1.6 is a maintenance release, so I have a great aside for this. So the 1.6 release is due out any day now, but the team has stopped the release. They pulled the Kanban cord, Kaizen cord, and they will not release 1.6 until the CI system is running more smoothly and some critical defects are fixed. And I really applaud the Kubernetes community for saying, look, we're going to throw away our release schedule until we fix these critical issues, and the 1.6 release is on current permanent hold until these issues are addressed. That is great behavior. They're not slave to the calendar, they're slave to the quality of the product. So kudos to Kubernetes. That type of stuff makes me, as somebody who's operationally focused, really excited, right? Stopping and doing a cleanup release and then holding that release until it's working. In 1.5, they added some primitives that were necessary to make the OpenStack pieces work, and Helm charts advanced to enough of a degree that it could get there. There's some stuff coming in operators and things like that that look like they're going to make this effort even easier. So I'm super excited. But what this is doing is it's using Helm, which is a Kubernetes primitive. So my first requirement was we're not going to deploy OpenStack on Kubernetes using a whole bunch of external automation and orchestration to just sort of poke Kubernetes. We actually want to do it using Kubernetes primitives, which is important if you don't want, if your Kubernetes cluster is going to do things besides OpenStack. It's a complete fail to me, somewhere on these slides, it's a complete fail to me if you say, oh, I'm going to install Kubernetes, and the only thing that Kubernetes cluster does is run OpenStack. Don't do it. That's not a good use of an underlay infrastructure. So the way this is being done is you can use that Kubernetes cluster to run other workloads, and then you can scale your OpenStack cluster up or down depending on actual need. Not say, oh, I need another Kubernetes cluster to run other apps. That ends up being a really bad thing. What it's doing is it's tagging. There's a feature in Kubernetes called tagging that allows you to identify different nodes, and we use the tagging so that you can put different workloads in different places in your cluster, so you still have control over where things are running, which ends up being important for OpenStack. There's something called daemon sets, depending on how you want to pronounce it, that allow you to take a container, schedule it through Kubernetes, but treat it like it's a trusted hosted mode, which you need to do for a lot of OpenStack services. So a lot of these charts are using daemon sets, which is not my favorite way to solve this problem, but it works pretty well. Databases are using stateful sets, so they have to have that persistent layer through Ceph. And then one of the things that the AT&T team really wanted was to have multiple sources of containers. So they're actually using the Stack and Kubernetes containers. You could use the Cola containers. You can start turning knobs. And it's one of the things I really like. There's a lot of choices that you can make in doing these deployments. So even though it's Kubernetes, it still isn't that opinionated. And so there's this balance between being too opinionated and being too open. And right now it feels like they've got a good balance. But there's a lot of hard work. So the networking stuff, which is confusing because you have 2 layers of networking, has to get resolved. You have to actually map physical networking into Kubernetes, which is sort of hard to do. You have to deal with a whole bunch of configuration injection, which OpenStack is just figuring out, and there's no consistent patterns. And storage is still very primitive, right? Installing Ceph with Helm charts, unless you have something like Digital Rebar that knows how to enumerate all the drives on every machine and then build Helm charts for you based on that enumeration, you're going to have trouble building a good storage infrastructure. Those are all solvable problems. We're looking for people who want to solve them with us and want to get this stuff accelerated, because that's how we operate. So those are all, I think, very solvable problems. The bigger challenge to me that we'll see in Boston is how OpenStack projects are going to handle some of the issues that are exposed by having immutable containers. And right, the community as a whole is going to have to decide to prioritize work that we expose with this. We'll probably find some hacky workarounds, like pinning services to machines, but that's not really where this should go, right? Hopefully in Sydney, we'll actually start having conversations about, hey, you know what, I want Horizon to be completely immutable so I can move it back and forth between different servers. I don't think any of these containers are there yet. So this is what the infrastructure looks like. If you go back to my earlier slides, this is significantly better. I was expecting we would stand up services outside of Kubernetes. The impressive thing with this is that every single service that you need to run OpenStack is represented as a chart. So Ceph, dashboard databases, Rabbit, it's all in containers running on the system. That creates some challenges because your software-defined networking and your storage are actually built back into Kubernetes, and the networking models are not that robust compared to what OpenStack is used to in that. And there's some projects, I think it's Curler, that is used to actually do Kubernetes networking through for Neutron. But the circularity of these things are tricky. Networking in Kubernetes uses something called CNI, which is a Docker interface, and it's surprisingly resilient in that you drop in new CNI plugins, and then the system recognizes that you have a new networking plugin, and it pulls it in. So it's very possible to take a Kubernetes cluster, add networking to it, and then have it sort of morph into a new beast. It's not clear yet quite how we're going to do those things with Neutron and fix all the pieces together. It's possible we could just sidecar it and attach Neutron to a different NIC. This is the place where the edges get fuzzy on what this stuff is doing. And then it's important for me that we don't look at this as an OpenStack only thing. You could say, I want these nodes to run OpenStack. I want to leave capacity for other workloads in my infrastructure. My expectation is that if you're doing this, you're going to make your VM nodes OpenStack only compute nodes. You won't try to squeeze some containers in around the edges, because I think that that's just a recipe for disaster. I'm sure people do it, but it's perfectly easy. Actually, the word is cromulent. It's perfectly cromulent to separate the workloads and say these functions are only for OpenStack Nova compute nodes, and these are for general purpose Kubernetes functions, and let things keep running. And I've already been talking to this slide. So these are technical challenges that remain. We still have to figure out upgrades, both for Kubernetes and for OpenStack. There's no magic bullet. There's still management tooling that's going to be necessary. Packaging containers is important, although it seems like it's okay. The thing that made Cola get very complex is that Cola was actually packaging containers to manage Cola inside of the deployment for Cola. Yeah. Which makes perfect sense if you look at what their code does, but they needed containers inside the environment to run Ansible for them. And we still have similar problems with this. You have to have enough awareness of the environment and the infrastructure to make things go. Docker, happy birthday. You're still only 4 years old. Right, we're still in a place where if we're doing this work, we're relying on the Docker engine to run the containers that are running our core infrastructure. And so, and all the Kargo stuff we did is Dockerized Kubernetes. So it's containers it's containers not containers in containers, but the deployment that we're using, all of the services are actually deployed as Docker containers. So any issues with Docker, if you find weird bugs, if they patch it, if they roll out a breaking change to the API, which they do every version, then your whole infrastructure is at risk. And it's not just, your whole infrastructure is at risk at layers and layers of your infrastructure. It's operating systems and hardware, all that stuff. But Docker is especially fragile. Right now, it's getting better, but it's still fragile. And things like Rocket or another container scheduling mechanism are still maturing along the ways. And so probably by the time somebody's really ready to do this, it will look better. It always has. I have to say I'm impressed with the pace of progress. And storage and networking we talked about. Cool. So, yeah. The operability is not solved, right, by fixing the Underlay platform alone. So you can't just put in Kubernetes and say, hey, the challenges I have operating OpenStack are now no longer challenges. The best thing that we can hope for is that the community operates more synchronously and they can share and get the benefit of working together. So the thing that I would love to see is that community can actually collaborate more on operations if people are using a shared infrastructure underneath it. That would be a big deal. Technical leadership has to decide that this is a legitimate and important way to do things because it will require code changes to implement into this mechanism. We have to fix the messaging. I know for a fact the board is working on this, and it's going to be an unwinding when we do it. I'm not even sure you can. I think that OpenStack, this is speaking as a former board member, OpenStack has to figure out what place they have in the hierarchy of data center infrastructure, and it might not be as high as we thought it would be a couple years ago, before Docker came and sort of disrupted the whole data center, how we deploy applications. I think it is, and along those lines, I still think it's necessary. I think that the way for OpenStack forward is to look at technologies like this, embrace them fully and collaboratively, and then find out ways that makes OpenStack stronger. Because from my perspective, the operators of OpenStack want this type of solution, right? They are operating Kubernetes. They're hearing that they're going to be operating Kubernetes. they're hearing that probably more, actually I know this, they're hearing they're going to be running a Kubernetes infrastructure or Mesos infrastructure or something like that more than they're hearing that they must run OpenStack. Because no developer shows up and says you must run OpenStack, but a lot of developers are showing up to their ops teams and saying you must run Kubernetes or Mesos or Rancher or Swarm or something like that. And so that is going to switch priorities really, really fast. Cool. Send the presentation. And I have questions. I'm happy to do questions now. I've fully done, this is like 2 simultaneous presentations. Because we've got questions about the presentation. I'm happy to talk about that. And then if you want to drill into what the tech is doing underneath the covers, yay, it deployed it. And I can take a second and actually show you how to figure out if you want to do, so you can totally replicate this stuff just as easily as I showed you. It takes about 20 minutes to install digital rebar. You can walk through the wizard. It'll set this stuff up. I'll take a second and show you how to figure out how to actually access the OpenStack cluster, and then I'll take questions. Does that sound good? Okay. So here in this cluster that I just built, I've got a problem in that Kubernetes networking space is internal to Kubernetes. Right? It doesn't have an external networking space unless you add a load balancer and expose ports through a service identifier outbound. Kubernetes is designed to talk east-west. You have to enable north-south communications if you're used to that type of networking terminology. So what that means is I have to go to my head node. So this is the node where I deployed Kubernetes. And when I open that node, I'm going to get a self-generated certificate. I'm going to need to log in, admin, I think it's admin. So the defaults, these are configurable, but admin change me, or is it root? I always get this confused. It's root, change me. This is Kubernetes. It's a bunch of APIs. If you want to use the UI for it, you do /UI. And this will give you the dashboard. So this is my fresh, minty Kubernetes install. This is the dashboard. Literally, this is, right, same thing. You could click through the Kubernetes wizard that we have, and you'd get Kubernetes set up, same thing. And then from here, it's installed a couple of different namespaces. So Ceph, default, so I have a whole bunch of net checker stuff. If I switch to the OpenStack namespace, you're going to see all of the, if you're an OpenStacker, all of the friendly, comforting project names that you're used to seeing. And each one of these is now running basically a pod providing that service. And if I go into Horizon, which is the UI for OpenStack, you will see my one Horizon container, because I only asked for one server, is running happily, and it is running on with this cluster IP. Now, this isn't the node that it's running on, it's the IP address that pod is advertised. It takes a little bit of time to get used to Kubernetes from that perspective. It's designed to be a distributed system, so you don't get, oh, here's the IP address of the node you're running or the VM you're running. It's here is a service entry point for you, and we will make sure the traffic gets from that point to your container. Right, 12-factor apps, different design. Anyway, so I'm going to take that. This is not a public IP. So I have not exposed this. I'm going to do this. There it is. So what I have to do is I have to SSH. So digital rebar sets up my SSH key, so I can SSH into all the nodes in my cluster for me. So it propagates my access. And I'm reading up at the top of the screen. So 147, 75, 64, 31. All right, so this will let me SSH into the machine, and then what I need to do is do a port mapping. So I'm going to map, I've already got 80, so I'll do 81 to the internal IP address to port 80. Whoops, port 80. So if you're not used to doing this with SSH, this is called a port forward in SSH, and what I'm doing is I'm saying, you're going to SSH into this box, And then you're going to let my local machine direct traffic on port 8081 to port 80 on this remote machine. So it's a traffic forwarder. It's letting me into the remote data center, if you will. So that's just going to look like an SSH connection, and now I have these ports running in the background. When I do that, 127, port 8081. So my 8081 on this machine is forwarded to my fresh OpenStack cluster, and it's going to come in and ask me for OpenStack, which should be admin and password. That looks great. Yay! All right, so this is it. In the course of doing this demo, I've actually gone through and done a complete OpenStack, a Kubernetes deployment, Helm install, OpenStack on top of it. So this is huge, right? It's a ton of technology all working together pretty seamlessly, and now ready for us to then take to the next level. So with that, that's the end of the demo. Questions? CNI, so CNI, Docker CNI is, it's the container networking interface. And so basically you can drop containers or executables into a directory and Docker knows to pick them up. Actually, it is a Docker thing. And so as you build new networking technologies, you just drop in containers into those directories and it'll pick those up, actually. So on this machine, this is the head node for my cluster. If I Docker PS this, is this big enough? It's okay. Okay. No, it's not. So this should scare you. It scares me. This is the containers that are running on this system to run Kubernetes and this networking and OpenStack all together. So this is the Docker container set. Yeah, tons of stuff going on, but that is how people are deploying Kubernetes. It's their containers on containers with containers, sidecar containers on more containers. It's crazy. Yeah, Paul.
All right, so two questions, not necessarily totally related. One is, when do you think this stuff will be ready for someone to actually run like a production OpenStack?
How big a scale? 10 node, like 100 node? Let's say 100 node. 100 node's a good number.
Let me ask a question first.
Yeah.
Sorry. I'll give you that guy. I am that guy. Because so if you go back to the OpenStack layer, did Neutron do get a provider network and all that stuff? Run instance, attach Fortinet and do all of that stuff?
It's partially configured. It's not completely there. So, yeah. So it's not using. I think it's using a flat Neutron. I'd have to go dig into the networking. This is where, so my co-founder, Greg Althaus, is enjoying spring break. So he'd be a better person to address those questions. And we're happy to, be in community and talk about them like that. It's not all the way there. There's some great conversations about trying to get that next level, and we have some ideas about how to do it. Neutron's going to be the bottleneck with this, without a doubt. Yeah.
Yeah. So even 10 nodes, because it's operationally.
Yeah.
It's scale point. Operationally, it's not that different to run 10 or 100.
No, it's not. So the question is, what's it going to take to scale this? I actually think with some serious dedication in it, which to me is 2 or 3 people working, it's about 3 months. Most of the problems that we're seeing are within sight of being solvable. If you were willing probably to compromise on certain operational challenges. But I think you could put a reasonable production workload in this pretty quickly. That's Greg and I asked Greg that specific question because we have people who are all right, is this going to take 6 months, a year, and he was more like 3 months of dedicated effort for it.
Yeah, I guess it feels like there's quite a few fairly large things to overcome around, like, your overlays on overlays and some other stuff where it's really going to be reliant on OpenStack to get their shit together as much as Kubernetes and the Helm stuff.
So the question is, how ugly is it going to be? And the nice and sort of the nice caveat on that is that if you needed it to go quicker, you could get uglier. So it would be entirely reasonable to do what I don't want to do, first pass, and say, you know what, we're not going to share this cluster with anything else. We're just going to make it an OpenStack cluster. And you could say, you know what, we're going to bond, we're going to have a separate network for Neutron and not try and commingle the networks. Those hacks, very doable, and that would solve your problems. The thing that's going to take longer is where you actually try and create some network synergies between them. Now, the idea of having network synergies between a VM and a container is huge. So I could actually start mixing and matching, oh, here's my containerized pieces, and here's my stateless pieces, and here's my containerized pieces, or my VMs, containers, and stateless, and mix them. Wow, that gets really cool. And it's actually logical thinking that Neutron could help build those bridges. So it's pretty straightforward. You'd probably also end up doing something like Calico or one of the real overlay network styles, less OVN or something like that, which I think is going to be harder to accomplish in containers.
Well, and also I think if you're like looking at Cisco or something for like a physical network that supports SDN,
right,
then maybe they would both use the Cisco thing and it would sort of just work with the physical switching.
So the question is, can we do it with physical switching? I don't think the Kubernetes stuff against physical switching is as advanced. So I think your laggard's going to be how well the Kubernetes pieces do it. Because I'll tell you, as much as I'm excited about Kubernetes on Metal, there's a minority of us that care, and so and this to me is a huge takeaway for the OpenStack community and for any project. If you are not cloud first, you don't show up, right? PlumGrid, who I thought had some really interesting technologies, they're gone, in part because they couldn't operate their SDN layers in cloud infrastructure. So the technology, the SDNs that are going to win, in my opinion, are the ones that are cloud enabled. So the Calicos and the Weaves, because even if they don't scale as well as like a Open Contrail, they're 80% of their initial use is going to be in cloud infrastructures, and the Metal's going to be the backstory. Even if it's big, it's still the backstory. Yeah. Question?
Yeah, I just wanted to ask you, I think a lot of it has to do with what's going to use the platform. So if you have requirements where you require like 200 millisecond latency, because that's what your business demands, you have a similar requirement, then you're going to have to look at host networking or SRV to do that physical, which is one of the things that, as you mentioned, is not nowhere near easy to do in Kubernetes. It's doable, but it's not easy. So that's going to be one of the challenges. The other challenges, which my colleague here mentioned, is that one of the problems to scaling this is going to be etcd. That's one of the problems that we're going to have, as etcd is very sensitive to latency. If it starts ripping apart, that could be issues. And additionally, I had a question, which is more around the way you do stuff, right? This is great for demo, try it out, 3-node cluster, awesome. But once you start going to production, this guy, you have a CPU utilization there, starts becoming a challenge, right? So you probably want to run stuff in a separate, set of machines, as opposed to like an all.
Yes, and so, boy, I can't. I'm not even going to try and repeat the great points. You're right, and one of the reasons why we're excited on the physical side is because all of those issues are real issues. Today, people are still, just writing apps for Kubernetes, there aren't that many people worried yet about I/O performance and networking latency. And I think that there's a whole raft of GPU enabled Kubernetes stuff that should come down the pike because people use it to deploy applications and pin. The stuff that we're showing you, there's no reason you can't do more segmentation for it and like separate your etcd cluster out from your Kubernetes API servers. And those are totally manageable things to do in these infrastructures. And so that, I think the real concerns, so part of my background and part of my frustration, the thing I start grinding my teeth about, is when I see a dev stack style upgrade, right? So I am distinctly not showing you a boot kube, which is the one node boot, Kubernetes one, oh God. Those things I think are really, they're handy for developers, they're really destructive for operators. And so, right, you'll notice our default OpenStack deployment was actually a 12 node cluster. And those are real operational concerns. That's what we need to be doing as practice deployments. It makes me very nervous. And we have this problem with the Ceph stuff that's being done here. All the testing is single node Ceph. So the idea of building a real Ceph cluster is not baked into the Helm chart yet. It's doable, but it's not the default behavior, right? It's not what you're going to see come out of Zool when they gate it. And that makes me sad. The operators need us to be doing multi-node testing. That has to be part of our daily routine. So, yeah. Yeah.
You kind of touched on it earlier where one of the problems with OpenStack is that you don't share the operational knowledge across from one cloud to another. And there's some reasons as to why that happens. But what do you see as operations moving forward? Because like for me, where I see it going is more of like the etcd operating model that CoreOS released with baking a lot of that into code.
Right.
That's where I see it going. We're still a couple away from that, but that's my perspective.
So the question is, where do I see operations going? It's a favorite topic of mine, so I will not fully answer it. If you haven't looked at site reliability engineering and read the Google Site Reliability Engineering book, go do that. When I look at serverless and Kubernetes, what I see happening is developers are tired of doing infrastructure. And this is where I see operations going. I think DevOps is a huge success. Developers want to own their code all the way into production. They don't want to mess with infrastructure in doing that. So they look at serverless, they look at Kubernetes or platform as a service, and they will totally own, I wrote code and made it go into production. They will not own how many servers are running, and are the SSH keys right, and are the certificates set up, and is the load balancer running. I think we're going to see a segmentation of concerns where a smaller operations-focused team, a site reliability engineering team, as Google would call it, is responsible for running your infrastructure and treated like an engineering team, like a development engineering team. I think that a lot of the ideas of developers writing a whole bunch of chef scripts to maintain infrastructure, I think is going out. Developers just don't want to spend their time maintaining infrastructure. It's going to be a specialized team thing, is my opinion. And I think we can, and to CoreOS's point, I think we can make it a lot better by having code reuse and built-in operations and automation and things like the stuff we do takes RAID and BIOS configuration and machine provisioning. It turns it into a basically a service you don't worry about. It's going to get better. But I think we're going to have much clearer boundaries again between operations and development. So, good question. Favorite topic.
So, along those lines, what do you see as the future for these gaps to reference in the public swamp? I mean, with containers, the kind of there's overlap, and they used to claim that no, they can coexist.
Yeah. So the question is Chef and Puppet, even Ansible. I think that the tools are really important, but the days that they are something that are ubiquitous for all developers to know how to do have waned. Chef recognized it. They did a really smart pivot with Habitat, and so they're owning multiple tool sets. But yeah, the idea is that a developer should learn Chef. And what Chef does and the way configurations are managed and things like that, I think have really changed in thinking because of Docker. So maybe I should step back. I think putting code in containers and then configuring containers with 12-factor apps and shared secrets and things like that have really reduced the need to manage machine configurations the way those tools were trying to do it. So we sort of changed paradigms. Now, if you look at down in the metal and what we do, those tools are still necessary. We use them. They're really important. But they're much more baked in. They're not something where people are writing a whole bunch of Chef cookbooks to deploy, stuff that you could deploy in containers. It's a great question. It's really a remarkable shift in the last couple of years. So, and if you spend a lot of time learning Chef, I'm sorry. It's still a great product.
Go down, or are they still running? And if so, how does the daemon set kind of respawn every parent?
I love that question. So the question is how Kubernetes smart is Nova? It's not. So it's not. This is not using Kubernetes container scheduling to move Nova to a new server if it failed. That's the type of stuff that's going to take some re-architecture. It's really saying this server runs this container, and then that container joins to the Nova infrastructure, and it's the Nova server. So it's not using Kubernetes to really dynamically map and move containers around. Now it will, if that container fails, Kubernetes, the kubelet will restart it because it's set to do that. And Docker will, that's behavior you get from Docker. But so you get some, but not that type of dynamic. I kept my containers going. That has to be OpenStack still.
It seems like you almost need properties of stateful sets and daemon sets for that to work. It seems like if the daemon set brings back up, compute, it's coming from the different IP address.
It's really a scheduler problem. So the idea would be if I moved my container, my Nova compute container to another machine, one, you don't want that to be on another Nova container. That would suck. Has to be a fresh machine. And then the IP address and the scheduling and the resources and all that stuff has to get fixed. And so Nova's not really set to do that type of dynamic, I'm in a new place, I have a new set of resources, I need to spin up a new place. Matter of fact, very few things are at VM management level. Right, even I think Mesos, the way Mesos scheduler works, it would, the assets are all static, so you would assume a node goes away, you're not taking a node and moving it someplace else yet. There are people who are working on using Kubernetes to schedule VMs, and they would have behaviors like what you're talking about, and they would be using Kubernetes primitives. So give me a VM from Kubernetes. That's a whole nother talk. I've seen demos, yeah. That might be the right question to close on. No, it's a very serious concern. So I think that there is a lot of knowledge and logic and automation and APIs and thought about how OpenStack works and why it works that way. And there are people the answer is sort of two. One is inertia within OpenStack and people who are used to consuming it and want to consume it. So I think that's very real. You get big telcos and people who've done deployments like CERN, and their migration, they need it. They are going to keep using OpenStack for good reason. the reason I like this approach is that then they can incrementally migrate to Kubernetes as they're ready to. And then the other side of it is I think that it's a much more complex problem than people realize to do VM scheduling. And so I'm not sure how well those semantics are going to map, because what Kubernetes does and how it treats scheduling is really different than what OpenStack does. And it's different for good reasons. It's just like the way we treat metal is really different than what OpenStack does and different than what Kubernetes does. And each one has its own abstraction needs. And I wouldn't mix them, right? I wouldn't tell you to use us if all you needed were VMs, and definitely not if you want containers, right? We use other open source technology to give you the right abstraction. And so that's the... All right. And I will let that be the last question. Thank you. I really appreciate the time. I hope this was helpful. If you have questions, please come into the community and play. We're happy to talk to you and innovate with you.